So let's open the books up to page 94. I'm going to give each of you a long piece of yarn and a couple pairs of scissors, and we're going to find some cylinders, and we're going to talk about circumference. One for you. One for you. One for you. There we go. Should be enough yarn there for one person. Yarn. So we're going to need yarn, a ruler, and, well, string. If you have any kind of string, dental floss, you name it, anything that can be used in that way, it will do. There we go. Back up to here. For you. Okay, who wants to go up to Roland's room and get me a basketball? And one for you. All right, so like it says in the book on page 94, we're going to be working with lengths. We're going to calculate the circumference of a circle or any round object. And we're going to be working with certain formulas. Now these formulas, I know I talked to you guys about them last year. You may remember them, you may not. But it's all about how to find the area of certain shapes. And the shape we're working with today is a circle. Thank you very much. I'll use that in a moment. So, today we are talking about circumference, which circumference, for anybody that doesn't remember from last year, circumference is the distance around a circle. If we were talking about a rectangular object like this book, we would use length and width. For a circle, the distance all the way around the circle is called the circumference. So on page 94, it gives us a definition for circumference. It says circumference is the perimeter of a circle. Remember, perimeter is just the distance around an object. So perimeter can apply to any shape, but the perimeter of a circle is specifically called its circumference. The abbreviation, the circumference is abbreviated with the letter C. And it says workers in many jobs often add and subtract, divide and multiply measurements. They may need to convert measurements or work with a formula. It all depends on what they are doing. So what jobs might involve working with circumference of a circle? Can anyone think of a job where you might need to be able to figure out the circumference of a circle? Offhand.
Math teacher?
A math teacher is a very good example, yes. Math teachers do need to know how to find the circumference of a circle. What if you were a carpenter? You think that would be important? Yeah, that's right. If you are going to be building somebody's home and it's going to have any kind of round shape in that home, knowing how to find circumference is a good idea. Not just carpenters, but anyone that's going to be doing any kind of trade type job. So if you were working as a gardener, as an example, if you were going to make a garden, there are people that are going to say, I want to have a garden that's circular. I need to know how to find the circumference of a garden, because if somebody says, I want a garden that is so big, you need to be able to figure out how big does that need to be. So we're going to start by talking about talking about how we can find the circumference of an object. And you'll notice the handout that I gave you looks very similar to the table there that we have in the book on page 94. Put those other pair of scissors on. Borrow yours, Charlotte, for a moment. Thank you. So, you were given this handout here. We'll worry about doing the warm-up questions later on. That's not what we're worried about right at the moment. And we will finish, we will fill this circle in first, actually, I suppose. So I drew a circle on the board. Probably could have drawn a larger one if I had a larger circle to go off of, but I don't. So, we have a circle on the board. And I've already told you that the distance around this circle, is called the circumference. C-I-R-C-U-M-F-E-R-E-N-C-E. So, on that circle there, the line that goes all the way around it, you can label that the circumference. The next part of the circle that we need to know is right here, this dot that's in the middle of it, and that is what we would call the center. Because it's in the exact center of our circle. Next, I'll just use one of these rulers as a loose. So if we have a line that passes right through the center and goes from one edge of our circle, so if we now have a line right here that goes from one edge of our circle to the other edge of our circle and it passes through the center, we call this, anybody remember from last year what we call that? A line that goes all the way across the circle going to the center? Okay, I'll give you a hint. The symbol we use for that is D. Anybody remember what it's called now? No? No, not densities in our science class. This would be... There you go. A little louder, Charlotte, so Madeline can hear you.
No.
She said, wait, believe me, Madeline, she said it. Diameter. Diameter. Actually, I guess if you want to tell Ashley, you can tell her to watch this video later too. So a line that goes all the way across a circle and passes through the center is its diameter. If I had a line that was going from here over to here and it wasn't going through the center, that's not the diameter. It's just a line that's going across the circle. It's only the diameter if it goes from one side all the way to the other side and passes through the center. And then the final thing on that is, if we go from the center, so now we have another line going from the center out to one edge. This is half of the diameter, and we call that the radius. So these are the four important things to remember, the four parts of our circle that we need to remember. Distance around is the circumference. The point right in the middle is our center. A line that goes all the way across and goes through the center is our diameter. And a line that goes from the center to the edge, or just to one edge, we call the radius. The radius is always half of the diameter. So the radius, which is just r, times 2 is going to equal our diameter, d. And if we know d, diameter, and we divide that by 2, that's going to equal our radius. So it's very simple to figure. If you know either the diameter or the radius, then you can figure the other one out by using these simple equations right here. All right. So number 2 says pick 4 cylindrical objects. Well, I went looking. There isn't a ton of them, but I have paper towel roll. I have this, even if we forget about the neck, this is still a cylinder right here. There's water bottle. I have a poster thing that Roland gave me that we can use. I have another poster thing here that Roland gave me that we can use. I have this tin can that we can use. I have this little tiny bottle of, what's this stuff called again? Hand sanitizer, there we go, thank you. Hand sanitizer, that's a cylinder. I guess technically this bottle of water, it's not a perfect cylinder, but it will do for we can call it a cylinder. And I'll show you what we're going to do. I'm going to start with my favorite cylinder in the classroom. It's got my, well, not just my favorite, but the best hockey team out there, the Montreal Canadiens on it. So, what they want us to do now is we got to pick our 4 objects. So we got our 4 objects. Just measure the circumference of this. So we have our string. And we're going to get ourselves a ruler. And what I do is I can say, I'm going to put my string right here. I don't have any more scissors there. I'm going to wrap this string all the way around my cylinder. Just like I do right now. See, the string meets the string right there. And then I'm going to cut the string right at that length there, so I know that it's, should probably cut maybe a tiny bit off that. There we go. So what I did is I had my cylinder, I took my string, I wrapped the string all the way around my cylinder so it just went around once. See? All the way around. And it goes around once. And it gets to the other side, and that's that. So that piece of yarn went all the way around my cylinder once. So I can say, remember we said circumference is the distance all the way around a circle. Here's my circle. This string went all the way around it and just covered it. So I can say that however long this piece of string is, that is the circumference of this Montreal Canadiens hockey puck, the best team in the NHL. So, what I now do is I can take my ruler and I can measure how long this string was. So, I'll have to do it on the table here. And when I measure that string, I'm going to use centimeters because I like centimeters. They're easy to use, they're fun to play with. And that string, 24 centimeters. So the circumference of my hockey puck, I'm trying to draw my hockey puck on the board here. So the circumference of my hockey puck, circumference is 24 centimeters. So now on your table, on the next page on this sheet here, so number 4 on this sheet here, I just measured a hockey puck. So you can write object, you can call it hockey puck. Right there underneath object, you can write hockey puck. And then circumference, I just measured circumference, so you can fill that in as 24 centimeters. Right here, so 24 centimeters goes under this line right here.
On the second page?
Yep, we're on the second page. So the first object was a hockey puck. Its circumference is 24 centimeters. So the first object is a hockey puck. The circumference is 24 centimeters. The next thing it's asking for is our diameter. What's the diameter again? Anybody remember that? Nobody? Alright, fine. The diameter is, remember, the distance across the circle that passes through the center. So again, the distance from this edge to this edge down here is not the diameter. It's only the diameter if it goes right through the center of our circle. And in this case, when I measure the diameter on my hockey puck, I get 7.5. So my diameter, my D diameter, is going to equal 7.5 centimeters. So you can fill that one in there. Maybe what I'll do is I'll just get these off the table so that they're not blocking the board. And then you'll notice on the table, the last thing it says is the circumference divided by the diameter. So here I have my circumference, 24. So 24, well, I'll write the equation. It's saying circumference, what they want us to do on this fourth column is they want us to take our circumference and divide that by our diameter. And in this case, it's going to be 24 centimeters divided by 7.5 centimeters. Anybody know what that equals off the top of their head? No? Okay, well I'll take my calculator out here. And we have 24 divided by 7.5. And I get an answer of 3.2. Okay, we're good with that one? 3.2. Alright, so now there's 3 of you guys here. I want everybody to come up here and take a cylinder, or if you have a cylinder of your own, and I want each of you, what you're going to do, since there's 4 things that we need to fill in here, I did 1, everybody else is going to do 1, and then we're all going to share our information to fill this chart in. So pick a cylinder, any cylinder. If you have a cylinder of your own at your desk that you prefer to use, if you have a water bottle, if you have I don't know, anything at all that you have on you that you prefer to use, or you can come up and grab one of these here, it doesn't matter to me. Look around the room. If you see other cylinders in the room, feel free to grab one of those instead. I'm just looking around at...
So what do I do? Just...
Okay, the same thing that I did. So what are you going to do?
Paying attention, I'm sorry.
Oh, well, that does help. So the first thing I did is I took my string and I wrapped it all the way around my cylinder until it meets back up. And since it meets right there, I take my scissors and I cut my string right where... around right to there, okay. So I want to cut my string, boom. So the piece that you cut off should go all the way around your cylinder, just like this. Yep. Yeah, that bottle of paint's perfect. There you go. There you go.
If it overlaps, is that okay?
Well, no, so see where it overlaps? And how much? Is it just a fraction or is it like overlapping a lot?
Probably not.
Okay, so just cut that tip off there and you should be good. No, a little further.
Well, I don't want to get your
Ah,
fingers.
you're good. Okay. There we go. So, once you've wrapped the string around your cylinder and you've measured it and you've cut the string to get that, we know that this string represents the circumference of that circle. It's the distance all the way around the circle. Pardon me, so take your ruler and measure how long the piece of string you just cut
What
is.
centimeter?
In centimeters, yes. So Amber, you're doing the hand sanitizer bottle. Hand san bottle, just right there. I know my chart's gonna look pretty awful on the board, but
I don't know how long this is. It's
okay.
like almost like touching it to 14, but it's like not. It's like probably two bars over.
So 14.2. So your circumference, Amber, is 14.2 centimeters. So now the next thing you want to do is you want to take your ruler and you want to go through and find the diameter, remember you take the ruler and you make sure that it's going to go through the center of your circle. So for you, you want to turn the bottle up, like turn the bottle almost like this,
Yeah.
and measure it across the bottom there. So going this way.
Yeah. Oh, this way?
Yep. And how many centimeters? Okay, well, let's have a look there. So that's about a little over 4.1, I'm guessing. So she's getting about, so her diameter, and again these, because we're eyeballing this, we're saying it's 4.1, actual 4.2, look like it could be in the middle, we'll say 4.2. So now the next thing you need to do on your calculator, what is your, so you're going to have...
So like 14.2 divided by 4.2?
Mm-hmm.
Three decimals 380 and then
3.38.
0.9523.
We'll just say 3.08. That's close enough. All right, now, Charlotte, did you get your circumference one figured out? Did you wrap your string around?
Yeah, 22 centimeters.
22. What is it?
That was good. No, that
22 centimeters.
Yeah.
All right, so Charlotte was doing the water bottle. Water bottle. And her circumference was 22
Yep.
centimeters. Okay, and so if you measure the bottom, did you get your diameter yet?
Wouldn't it be like the same?
Your diameter would be from here
Oh.
to here. Oh, use your ruler. So on the ruler, just measure from this edge to that edge. Remember, we want to go right through the center.
Like
7.
7.
Okay, there we go. And then she has her diameter equaling 7 centimeters. And again, these aren't 100% to the millimeter accurate. We were just eyeballing these, but they're close. So now, Charlotte, I don't know if you have a calculator handy, you can grab one out of the bin. But you need to do 22 centimeters divided by 7 centimeters. And what is that going to equal? So again, you can feel free to grab a calculator. So 22 divided by 7.
Oh no, this is 3.14 and then
3.1, what is it?
I don't know, a couple other numbers.
Okay, oh, so Charlotte, I think, has actually been the most accurate so far. So she got 3.14. Excellent. What about you, Sam? So you were doing the paint bottle, right? The paint bottle. All right, so 13 was your circumference? All right. And what was your diameter? 4. So you and Amber's bottles were pretty close. So what is, so we have 13 centimeters divided by 4 centimeters, and we get 3.25. What pattern do we see in this column?
3. You also have 3.
They all are starting with 3.
Other than the coffee cup. Oh no.
No, 3.2,
Yeah.
3.38, 3.14, 3.25. So, number 5 says, look at the numbers in the last column in table 4. This one right here. What can you conclude about the length of the circle's circumference compared to its diameter? So, I guess what they're trying to ask is when we compare the circumference of a circle to its diameter, we always seem to get a number that is just slightly over 3, right? 3.2, 3.1, 3.3. So, what can we say about that? I was gonna find the circumference of this basketball, maybe later on. Anybody? Do any of those numbers that we have in that 4th column look familiar in any way to anybody? Anyone see any of those numbers before?
X divided by 2 equals 3.
That's not what we want. So there's no number up over here on this column that looks very familiar, possibly tasty and delicious.
Pie.
Oh my, she said it. That's right. So, what we've actually discovered here is this is how this relationship, the relationship between a circle's circumference and its diameter, is always going to be equal to, she said it a second ago, Charlotte, that delicious number. Say it one more time. Anytime now. It's called, you're just not saying it, okay. It's called pi. Yes, so for number 5, what do we notice about this relationship? Well, we notice that a circle's circumference is always a little over 3 times its diameter. And we call this relationship pi. So if we wanted to know, if I wanted to figure out what pi is, if I take my circumference and I divide that by the diameter of a circle, it's going to equal pi. Now you're probably saying to me, well, no, they don't all equal pi. The only one here who got pi was Charlotte, because hers was exactly 3.14. And the only reason that that's the case is because we were eyeballing it. If we had laser precision measurements here, and we could have measured all of our cylinders with laser-like precision, we all would have got 3.14. I'm a little bit off. Again, human error. We got 3.2. Sam was a little bit off. She got 3.5. Amber was a little bit off. She got 3.38. But we're all very, very close, and in Charlotte's case, exactly right on pi. And this was something that was discovered a long time ago. This is how we have found, how we discovered what pi is. If you take any circle or any round object, even something like a cylinder, or sorry, it's not a cylinder, a sphere, and you take its circumference and you divide it by its diameter, it will always equal pi. So basically what this is telling us is that the circumference of a circle, the diameter of a circle, and pi are all linked together. If you know any 2 of these 3 things, you can then find the third one. And since pi is always going to be 3.1415 9 on and on and on, you're always going to know what pi equals. So if you know the circumference, you can find the diameter. If you know the diameter, you can find the circumference. And the equation for finding circumference is circumference is going to equal pi times the diameter. But since we're writing this in algebra, we don't really need to put our time symbol in there. We can just say circumference equals pi times d, or diameter. So then 5b says, mathematicians use the Greek letter pi, which is this symbol right here, to represent the ratio of the circumference to the diameter of a circle. The symbol for pi is, well, this right here. Pi is a number that has no end. So I wrote 3.14159, and then these numbers go on and on forever. As you can see on the page there, they have a whole lot more numbers written down than I do, and that's not even all of them. They can keep going on and on. And if you started writing pi today and wrote pi, the digits for pi, from now to the day you die, even if you live to be 200, you still will never get to the end of that because pi never ends. It's infinite. It goes on forever. However, most of the time, we just use 3.14. That's what Charlotte got because it's just the easiest. And unless you're doing really high precision calculations, you really don't need to go beyond 3.14 for most things. So whenever I say, what's pi worth? I hope everyone remembers 3.14. So how close were your answers in the last column to pi? Well, we had one that was right on, and 3 that were just slightly over. So number 6 says extending your understanding. These are 2 formulas for calculating the circumference of a circle. One of them is pi times the diameter, and it's often written, the way I have it written right here. The other one is, for circumference, is 2 times pi times the radius. Well, since I already told you over here that the radius times 2 is the diameter, I could rewrite this equation to say C equals pi times 2 times r. Or, to make it simpler, C equals pi times 2r. Or, sorry, it should be written as, not like that, it should be written as 2 pi r. So either one of these equations right here can be used to solve for circumference. If you see a circle and it's only giving you the radius, you can use this equation. If you see a circle and it's giving you the diameter, you can use this equation. Any questions so far? Am I going too quick or is this making sense? Okay, I'll take your silence to mean that it's all good. So then, it says try each formula, in number 6, try each formula to calculate the circumference of each circle. Express your answer by using 2 decimal places. So, everybody take your calculator out and do question 6 on the bottom of page 71 here. And then when you're finished that, you can flip over to the next page and we'll go over how we've used these equations here. So everybody do those 2 and then we'll go over it. Okay, so for 6A, for 6A, they're telling us the diameter across that circle is 5 inches. So, or sorry, no, that's not inches, that's feet, 5 feet. So, since they're giving us diameter, we can use this equation right here. And we'll say C equals pi time, or well, we don't need to put the times there, pi d. We already know the value of pi, and we'll just keep it simple, so we'll say 3.14 times our diameter. And since we know our diameter is going to be 5 feet, 3.14 times 5. So if you have your calculator out, 3.14, or if you have a pi button on your calculator, you can just hit that. Times 5. 15.7. If you push the pi button, instead of just typing 3.14, you might have got a different decimal. We'll see what happens if I hit the pi button. Times 5. No, 15.70, so we don't need to put the 0 after the 7 in that case. So 15.7 feet. That is the circumference around the circle in 6A. And for 6B, this one here is not giving us a diameter. It's only giving us a radius. It's halfway across the circle. So I can take a whole separate step and find, using this equation here, and work out D, and then use this top equation. Or just to simplify things, I can use this equation right here and just enter the value for the radius instead of worrying about the diameter. So C equals 2 pi r. 2 times 3.14 times, in this case, it is 3 meters for our r. So r is 3 meters. So now I can, on my calculator, just type these 3 numbers in. 2 times pi times 3 is going to equal 18.85 meters. Okay. So, once we have that filled in, we can flip the page over to this one right here, on the job 1 page here. And it says that on the job 1, work with formulas. It says most items are imported into Newfoundland and Labrador. So if we're still following along in the book as well, this is going along with what's happening on page 96. In these sheets, it's page 72. So most items are imported into Newfoundland and Labrador on ships and planes. The cost to ship a package is often determined by its weight or its dimensions. When we ship items to other provinces, Greg uses the formula L plus G, where L is the length of the longest side, and G stands for girth, and girth is the distance around the package. So they're showing you a rectangular package. The best thing I have as an example would be to use something like this box here, Special K. Special K. So, well, they're showing it as the distance all the way around the box is called the girth. So going around like this, similar to the way we did it with our string in the circle. We can take a string, get it to go all the way around the box, and that would tell us our girth. The other way we can do it would be to take a ruler to measure how big this side is. In this case we have 4.5 centimeters. And then to measure this side, 19.8 centimeters. And we know, so if this side here was 4.5, we know the opposite side that's the same size is also 4.5. And if this is 19.8, then we also know that this is 19.8. So essentially we have a situation where we have 4.5, 19.8, 4.5, and then 19.8. We can add those together, simple enough. So we can do it quickly in our head. If you need to, you can use your calculator. .6 centimeters, because that's how far around it was. Now, I can also then measure my that's in inches, we want centimeters. So my longest side, which would be this one right here, still doing it wrong because I'm looking at inches. Well, this is the 27.5. So our girth, this here was how we found the girth. We added up all the sides going around it. Okay? So we'll say that girth, G, equals 48.6 centimeters. And L, the longest side, equals 27.5 centimeters. I'm starting to run out of real estate on the board here. I'll have to erase this off in a second, but I can still use this top corner. So, this is telling us that the equation he uses when he's shipping this package is the length plus the girth. So if we have length plus girth, that would be 27.5 plus 48.6. Add that quickly. Plus 27.5 equals 76.1. So the first equation that it gives, so does everybody understand where we get girth from? No, okay. Well, let's look at our book even. We'll look at our textbook that we have here. Here is our wonderful Math at Work 10 book. The girth of this book, so which of these sides? So this has three sides. We have this side, we have this side, we have this side right here, okay? Which of those is the longest? Right, so going up and down, this is probably, going up and down is definitely the longest, okay? So this is what we will have as our L, our length. So what I will do is I will just, is everybody okay with circumference? Can I erase this? Great, okay. Everybody's good with this diagram of the circle? All right. And everybody filled their chart out already so I can erase this? Excellent. All right. So getting back to what we were saying, we know that L is going to be our longest side. So this is our longest side right here. And where did I put that marker? I just had it. Oh, there it is. So I'm going to just keep using centimeters because those are the ones I like. So we've already determined that this here is going to be our longest side, so I'm going to measure that in centimeters. I get 26 centimeters. So our math book, the length of it will be 26. Hello? Okay, so we have our length, because we just measured from here to here. That is our 26 centimeters. Now girth, this was the hard one, G. It's a new word, we just learned it today. I think actually this book has a nice little definition for it. Yeah, so this here is telling us that the girth is the distance around an object at a 90-degree angle to the length. So here's the length. So the girth is going to be the distance around the book this way. Okay? So in order to find the girth, I'm going to have to add all four of these measurements together. Or I'll show you a slightly simpler way to do it. So I'm now going to measure this length right here, which is the first measurement I need for my girth. Here I have it being 21.5. So the length of the book this way, or the distance I should say, of the book this way is 21.5 centimeters. So the first term in our girth will say 21.5 centimeters plus. Now what I'm going to do is I'm going to get this distance right here, which is really small, so I'm not even going to bother with that ruler. I'm going to go back to my smaller ruler here, and I can measure that that distance here is 2 centimeters. So this distance right here is 2 centimeters going across this way. 2 centimeters. So now that I know that this length here is 21.5 and this length here is 2, I know that this length here is also going to be the same as our first one. So 21.5 centimeters, and that this length going here on this side is also going to be 2 centimeters. So our girth is what all four of these add up to. So 21.5 and 21.5 is 43. And so 47.5. So our girth is going to equal 47.5. Girth equals 47.5. So this book's girth, remember it's a funny word. We're talking about it for the first time today, but it means the distance around something. And in this case, the distance around something that has a 90-degree angle. The distance around a round object would be its circumference. So, in this case, the girth of this textbook is 47.5. So the final equation, if we want to work this whole thing out, it's going to be the length plus the girth. So length plus girth equals. So in this case, we have 26 centimeters plus 47.5 centimeters. And that's going to equal 73.5 centimeters. So again, that's how we find girth, is we add the distance of all four. 1, 2, 3, 4 together. However, I have it written like that. The other way I could have done it to find my girth, and we're still talking about the textbook here. I found out first that my first length was 21.5 centimeters. I found out that my second length was 2 centimeters. So rather than writing it out really long, this took up a lot of space on the board. So to shorten this equation, I can just say 2 times this plus this. So this would be 2 times 21.5 plus 2 would give me 23.5. That should just be 47 on the dot. Which means that this whole thing should just be, there we go, I'm trying to add an extra half centimeter onto this whole thing and not even realizing. Oh well. So 2 times 23.5 is 47. So then I can, so rather than going and writing it out this way, I can write it out this way. Now, if this was a test, an assignment, an exam, anything like that, if you use this method or if you use this method, you're right either way. So whatever one you feel more comfortable with, that's the one you should use. But I just wanted to point out to you that you could use this method or that method and still get the same answer. And then once you have your girth, you just add it to your length to get this measurement here. Okay. So after that, let's get back into that sheet. All right, so this is a steel shipping tube Greg received from Vancouver, has a diameter of 1 meter and a height, oh sorry, we'll go back to A, that was, because A involves this box here, or A box. So A says a box bound for Calgary has the dimensions shown in the diagram. And the diagram shows the length to be 10 feet. And then the other two measurements in girth are 5 feet and 18 inches. So as they show us in the example there, to solve for that, it says the length of the side is 10 feet. The girth is 5 feet plus 1.5 feet. So it's going to be 5 plus 1.5 plus 5 plus 1.5, which is going to equal 13. So the girth of the box in that example is 13, and Greg calculates the length plus the girth measurement of the box to be 23 feet, because he had the 10 feet plus the 13. Then for B, it says a steel shipping tube Greg received from Vancouver has a diameter of 1 meter and a height of 3.6 meters. What is the L plus G? Well, in this particular case, we need to use pi times 1 to get the girth, because pi times the diameter tells us the circumference, and that is the distance around the cylinder. So in order to find the girth of the cylinder, it's the same as finding its circumference. So 3.14 times 1 is just 3.14, and it tells us the height of that cylinder is 3.6. So 3.14 plus 3.6 equals 3.74. That's when we take their length plus our girth. So now at the bottom of page 72 here, they give us a rectangular prism and a cylinder. And I'll do both of those on the board. And then you guys can attempt to do the questions on the next 2 pages on your own. So I'll do these next 2 examples up on the board. first thing we have here is a rectangular prism for A. So for A, we have excuse my poor drawing ability, but there is our rectangular prism. It's telling us that this length right here is 65 centimeters. They're telling us that this length right here is 80 centimeters. And they're telling us that this length here, well, they're saying 2 meters, but since our other two measurements, these are both in centimeters. So we want all of our measurements to be in the same units. So if they're telling us that this here is 2 meters, how many centimeters are in a meter? And if you're not sure, it's on the wall.
10.
Nope.
10.
Centimeters in a meter.
What?
200.
That's right, this should be 200 because there's 100 centimeters in a meter. So if there's 2 meters here, this would really be 200 centimeters. Now what you're thinking of, Amber, is millimeters. There are 10 millimeters that make up 1 centimeter, but you need 100 centimeters to equal 1 regular meter, and 1,000 regular meters to equal 1 kilometer. So yes, excellent, Sam. 200 centimeters is that length there. So since this 200 centimeters is bigger than this and bigger than this, we know that this length here has got to be our L. Our L is going to equal 200 centimeters. Remember, the equation we're trying to solve for is going to be L plus G. We know our L already is now going to be 200 centimeters. Now we want to figure out our girth. Remember, our girth is the distance around this object. So essentially, it's the distance around this rectangle here on the end. So what I can do is I can use that other equation. Girth is going to equal 2 times 65 centimeters plus 80 centimeters. It's going to be 2 times 80 and 65 is going to be 145 centimeters. 2 times 145 is 290. So that's the way I find simplest. However, if you would have found it easier to write it this way, G equals 65 centimeters plus 80 centimeters plus 65 centimeters plus 80 centimeters. Either way, you're going to get the same answer. 65 and 80 is still going to be 145, plus 65 is now going to be 210, and then 210 plus 80 is going to be 290 centimeters. So, okay, so I'll just finish this one up and I think that'll probably be the end of class. 200 plus 290 centimeters is going to equal 490 centimeters. So for the your turn section right here, letter A, the answer is going to be 490. So I should have time to do B if I move quick enough because we still have 7 minutes. Any questions about this one? Yes, no, maybe, okay. Yeah, I take your silence to mean you're good. Everything's good. So I'll erase this very quickly. And we're now going to move on to B. B gave us a cylinder. So we have our circle here. There's our cylinder. Again, excuse my poor artistic abilities here, but I'm doing the best I can. So this gives us a measurement that goes all the way across the circle and through the center, and they're telling us that it is 14 inches. So that's our diameter. And they're telling us that the height of this cylinder is 2 feet. All right. So, what I can do is, this is in inches, correct? That's in feet. So the easiest thing for us to do if we want to avoid dealing with fractions would just be to turn this into inches as well. So how many inches are in 2 feet? 24. Thank you very much. So 24 inches. So now we're working with the same units. It's easier to deal with things if we're dealing with the same units in both. Instead of 2 feet, we have 24 inches. This is 14 inches. So the first thing we need to do is well, the longest side, we already know the longest side here is going to be 24 inches. So in our equation for length plus girth, we know our length is already going to be 24 inches, plus whatever we discover our earth to be. Now girth, remember, is the distance around, and we already discovered that the circumference is also the distance around. So I can say that circumference equals girth, and if I know that the circumference equals pi times the diameter, I also know that the girth is going to equal pi times the diameter. And in this particular case, we have 3.14 times 14 inches. There's my calculator. So pi times 14 is going to equal 43.98 inches. So my girth is 43.98 inches. So 24 plus 43.98, pardon me, that's going to equal 67.98 inches. And if somebody wanted to know what that was in feet, all you need to do is take this number and divide it by, anybody? Inches into feet, you divide by 12. So if we wanted to know what this was in feet, we'd just have to divide it by 12. And since I know that 12 divides into that 5 times evenly, that'd be 5 feet, 7.98 inches. Any questions on that one? Okay. Well, if that's the case, I'm going to allow you guys to do questions 1, 2, 3, 4, 5, and 6 on these 2 pages. But since we have 2 minutes left, you guys can just relax, and we'll do those. I'll give you guys time to do those questions tomorrow.